Welcome to the big show, ladies and gentlemen. We're back here trying to talk about getting understanding of how in the world does our world actually grow. So, with that in mind, ladies and gentlemen, what we're talking about is seafloor spreading. And let's get right to it, since you've already been diving deep into this information. Now, I initially asked you to answer this question: which ocean is growing larger? Which one is shrinking? Strange question, but obviously, if you've delved into understanding exactly what's going on, and in terms of specifically the mid-ocean ridge, we come to realize that the Atlantic Ocean, believe it or not, is currently growing larger. The interesting thing about the Pacific, and I'll show this momentarily, let's dive into the Google Earth. As I mentioned before, we recognize that this huge mid-ocean ridge right through the Atlantic Ocean is essentially creating the Atlantic to grow larger and larger. In other words, the United States and South America is moving in opposite direction of where Africa and Europe is moving. However, to get you to understand why is the Pacific so large when in fact it still also has these ridges, probably in the South Pacific, but if we look in the North Pacific, right up through here, right up the northwest part of the United States, over into uh, Russia and Asia, all of the different parts of Japan and China, this strange line, which we come to realize is the Ring of Fire, and you think about all of the action, all of the different volcanoes and earthquakes, so many times are occurring here. What's being created is the ocean floor is, and we'll talk about this, being subducted or crashing in this area. So this dark line is essentially the ocean getting smaller here. And what that's creating is all of this action right all the way through down into this section of the southern Pacific. All of these dark lines are trenches. So the Pacific is actually slowly shrinking. Anyway, back to our little situation of understanding seafloor spreading. We've come across, obviously, this picture of where the oceans are spreading apart. And essentially, what we've come to realize is these huge mountain ranges. Now, moving forward, I mentioned we came across this information through World War II. So, as I mentioned, the sonar equipment found that there was a huge ridge or a huge mountain range in the ocean. Think about it. We had this understanding or a thought process that, gee, the ocean floor should be flat. Well, in reality, far from it. So, luckily, and I say that in a weird way, luckily we've come across through the World War II that our ocean floor actually has very many details that explain seafloor spreading. So I mentioned this picture, something similar to what you have in your notes. Hopefully what you've come to realize is that through this bird's eye view, we recognize, gee, let me clone myself. Two of me. Interesting. The mid-ocean ridge is this little line here, and obviously what we've come to realize is the lava is flowing out. Now, important to recognize what has really occurred. In order to explain this entire process, let's dive back into this picture here. The ocean floor is spreading apart, kind of like a constant conveyor belt. So on both sides of this ridge, where the lava is flowing out, the floor is moving like a conveyor belt. So whatever's being created here, like this little green blob on the conveyor belt, is being moved away from the ridge. So keep that in mind. When we think of a conveyor belt, think of the ocean floor. So seafloor spreading, the ocean floor is spreading apart from both directions. Now, to get back to this little situation, what I want to point out now is here's the lava being created. And the interesting part is it's a constant process. Much like Hawaii has these lava flows, the lava in the mid-ocean ridge is continually flowing out. So what it creates is this layer upon layer upon layer. So this layer closest, what I'm pointing out here is the greenish color, is older than the lava that is being formed right now. So if we can fast forward this process, a few million years later, now all of a sudden, here's that initial green color. Now I'm adding this tan rectangle. So what I want to point out is this tan color is older than the lava that's being created right now. However, it's younger than this green color. So hopefully you recognize what we're talking about. So if I move forward, which spot on the oceanic crust is the youngest, which one's the oldest? And I give you two spots. Spot B, which is, close to the ridge, or spot A, all the way on the farthest point from the ridge. Which one's the youngest? Which one's the oldest? Think about that for a second. It should be a real easy answer. Well, what I want to point out is the furthest. Well, first off, let's think about it. We can identify that question by figuring out what are the three pieces of evidence that the seafloor is actually spreading in the first place. Well, number one, the molten material. And this is kind of a stagnant or static picture of it. You can see this would be continually creating all of this lava. That's the important thing. It's always coming out, this molten material. So it's flowing out of the ridge. That's number one. So geologists have dived deep into the ocean. They've actually found the ridge, and they constantly see this lava coming out. The second point of evidence, we have come across the magnetic poles have flipped over time. What does that really mean? Well, in this picture, I identified different layers, which I was trying to show previously. How do we come across this? How do we know they're actually different aged layers? Well, the iron in these layers point towards the magnetic pole. The interesting thing, though, what we've come to realize, that when we look on the ocean floor and we look at these iron filaments, they point in different directions. So that leads us to realize that the magnetic poles over time have flipped. In other words, right now we are pointing towards the North Pole. Our magnetism emanates from that North Pole. That hasn't always been the case. Other times in the past, it's been the magnetic south. So what we come to realize in this picture, let's go back to this, and this will help us understand where's the youngest, where's the oldest. Here's those layers again. So we got the most recent, in this case, the tan one. So what we've come to realize, since this is a younger situation, let's say it's happening 500 million years ago, and the North Pole was where the magnetic pole is. All the iron would be pointing towards the North Pole. Well, time passes, and let's say 250 million years ago, now the most recent layer is being created. And it just so happens now at that point, 250 million years ago, now all of a sudden the magnetic pole is facing south. So now all of a sudden that the iron that's being created is now coming out pointing towards the south. We would actually see all these little pieces of iron as we moved from the ridge towards a continent. the iron flip-flopping back and forth. You could actually see them pointing in different directions. Let's say we go back a million years ago. Now all of a sudden here's this yellow layer, the most recent being occurred. Now it flips again. All of a sudden you start to see the iron pointing back towards north. So we would actually see a flip-flop of all these iron pieces that are in the actual ocean floor. Kind of strange, but it leads us to realize that now we can date the layers. We can figure out their dates. The last bit of information, drilling samples. We have actually found through drilling at different spots the actual age of the floor. So the last thing I want to point out, we bring out these drilling stations. Let's say we put a drilling station close to the ridge. We find that these are the youngest rocks, right close to the ridge, whereas the oldest rocks are the farthest ones from the ridge. In other words, closest to the trench or closest to the continents. So if I came back to this picture of the Pacific Ocean, all through here is the oldest rocks, interesting enough. And somewhere in the middle is going to be wherever there's a ridge, and it's kind of down here, it would be the youngest. However, it's much easier to recognize here. All this spots right here, which is also subduction. We'll talk about that soon enough. This is the oldest layers, whereas right through here would be the youngest material. So keep that in mind. So back to our little situation. To answer that question, where's the oldest? Obviously, it's going to be closest to the continents. And the youngest, obviously, is going to be closest to the ridge. So hopefully that explains everything, folks. If you have any further questions, make sure you get a hold of me. And as always, all the best.